Okay, guys, yesterday we started with hyperbolas. I'm going to wrap up hyperbolas today, but I'm going to just give you a really quick rundown of what we saw yesterday. When we're talking about hyperbolas, gentlemen, it is the set of points in a plane such that the absolute value of the difference of the distances from two fixed points called the foci is constant. So what did we talk about yesterday? We had said that if you take this distance, the distance from x, comma y, to this foci, and let's just call that d1, okay? And then I have a distance from that same point xy to the other foci, let's call that d2. All this is saying that is that if you have a hyperbola, okay, the difference of any point on the hyperbola to the foci, the difference is going to be constant. That's all it's saying. So if that difference is, let's say, 5, then the difference from this distance minus that distance is also 5. So that means that the distance from this point to this foci minus the distance of that point to that foci is also that same constant, if it's still going to be 5. Okay? Now, the distance, okay, this constant distance, or rather, this constant difference of distances, that is equal to what's called our transverse axis. Remember, the transverse axis is the axis that is where the vertices lie. So this constant difference equals the length of the transverse axis, which is the absolute value of 2a. Something really good to understand and know. So that constant difference, for example, we had said that it was 5 here. Then the distance from this vertex to this vertex is 5. Okay, guys? Remember that always. Make a note of that. Okay. Then we went on to show the formulas. I'm not going to talk about this again because we already talked about it. It's pretty self-explanatory. I'm not going to waste your guys' time. Just remember, unlike the ellipse, it's not that A will be bigger than B. No. If I have the positive 1 is x squared, that means my transverse axis from vertex to vertex is the x-axis. Okay? If I have that my y squared is positive, that means my transverse axis, which is from vertex to vertex, is the y-axis. Okay? You with me so far, my friends? Okay. We talked about formulas. We didn't really talk too much about when the center is 0, 0, but the formulas are right there. You can learn them and memorize them. What we talked more about was when the center is HK. Again, this is a matter of memorization. A couple little tricks, a couple little things that you may want to just try to remember. This is kind of the reverse of the ellipses. When you have a horizontal or x-axis transverse axis, the k's will be the same. Okay? The k's will be the same for the foci and the vertices. And when you have a vertical transverse axis, okay, the h's will be the same. So it's kind of reversed. Okay? I tried to always show you, little nuances that I noticed, and that's one of them. So try to remember that, okay? Try to remember that, guys. Okay, now, yesterday we talked about this one. I'm just going to go through this really quickly again, just to make sure that you guys are with me, and then we're just going to go ahead and continue the whole entire lesson. All right, so first of all, I wanted you to see how easy it is to get all the points just from looking at a hyperbola. First of all, it's an up and down hyperbola, so my transverse axis is going to be the y-axis. That means the conjugate axis will be the x. My A represents the distance from the center to the vertex. So I've got plus or minus 3, and I've got 0, 3, 0, negative 3, all because I can just read the formulas from the graph. My C, I don't have a B yet. My C, that's my foci, So that's plus or minus 4. The foci is always on the transverse axis. So that's 0, 4 and 0, negative 4. To find this b, the b is important, guys. The b is going to give you their quote-unquote covertices, but they're not really covertices. We don't have covertices here, but we're going to call them imaginary covertices, okay? And I'm going to show you again why and how that's so important. If you remember from our formula, c squared will equal a squared plus b squared for a hyperbola. So that means that 16 will equal 9 plus b squared, so b squared will equal 7, so b equals the square root of 7, okay? That's the square root of 7, plus or minus. All right, what this does, guys, just like the a and the foci go up and down in this case from the center, since this is the b, this is the imaginary covertices, we're talking about the conjugate axis. Square root of 7 is a little less than 3. So go 1, 2, less than 3 to the right. Then go 1, 2, a little bit less than 3 to the left. Why is that so important? When we're graphing and you have the b and the a, if you connect the dots here, guys, and I mean literally, it's that easy, okay? And you make a line, an imaginary line, going through the center and the corners. Guess what? You have your asymptotes right there. If you wanted to find the formula for that asymptote, well, let's look at this first guy here. My y-intercept is 0, and I went down 1, 2, 3 over 1, 2. Well, kind of over 1, 2, 2 and a little bit, down 3 and over actually square root of 7, right? So technically, it'd be plus or minus 2 over square root of 7, which then I have to conjugate. So plus or minus 2 square root of 7 over 7. How did I get the plus or minus? Well, this is a negative one. Let's look at this guy here. Y-intercept is 0. I went up 1, 2, 3. Oh, and I should have put 3 there. Stupid. Sorry. Up 1, 2, 3 over square root of 7. So that's how you get plus or minus square root of 7. You don't even need to memorize the formula. You just got to know how to read a linear equation, a line, and you do know how to do that. Yes, sir. The answer here is basically everything that I have put here, and then I added the asymptotes here. Okay? I added the asymptotes. I wanted to add that just to show you what that blue line and that red line represented. They're not real lines, they're asymptotes. They're just boundaries for the graph. Okay? Now let me show you now, this was going backwards. Now let's go forwards and show you how really simple hyperbolas are. And believe it or not, I'm going to show you with a very complex looking word problem. The Loran navigational system, and this is true, is based on hyperbolas. Two stations send out signals at the same time. A ship notes the difference in the times at which it receives the signals. Remember, it's calculating the difference because isn't that the definition of a hyperbola? It's when the distance from a foci to any point on the hyperbola is constant. So that's why they're looking for that difference. The ship is on a hyperbola with the stations at the foci. Suppose a ship determines that the difference of its distances from two stations is 50 nautical miles. Remember, guys, that that's the D1 minus D2 that's constant? So doesn't that, just out of curiosity, doesn't that also equal 2A, which is the transverse axis length? Remember we just talked about that when we first started this review again? You guys with me? We talked about this over here. This, guys? Remember? Okay, so that's where I'm at, just in case you're like, where is he getting this from? So I just want to point that out. The stations are 100 nautical miles apart, okay? And write an equation for a hyperbola on which the ship lies if the stations are negative 50, 0 and 50, 0. That little 0, okay, that indicates to me that it's going to be an x-axis transverse. So basically, I'm going to do a little sketch here to help us all out. I've got This hyperbola, ugly hyperbolas, I'm sorry. Here's my foci. Here's my other foci. Remember what they said, that the stations were 100 nautical miles apart. So that makes sense because here's the center. So from the center, 50 to the right, 50 to the left, that's 100. Okay, is everyone with me so far? Now, if we say that 2a is equal to this constant difference, well then that means that a will equal 25, right? Because 2a equals 50, a would equal 25. Don't we already know that my c is 50 here because they told us those were my foci values? So let's do some math, guys. C squared equals a squared plus b squared. So c squared is 50 squared, which equals 25 squared, plus b squared, which is 2500, equals 625 plus b squared. Subtract the 625, you got 1875 equals b squared. Okay. All I want is to write an equation for this, correct? Well, my transverse axis, you know, is the x. My conjugate is the y. Okay, I can't fill any of this out until I write the formula down. So don't I have x squared over a squared, which is 625, plus y squared over b squared, which is 1875, and that equals 1. That's my equation. So what's my a? The square root of 625, so plus or minus 25. What are my vertices? 25, 0, and negative 25, 0. What's my b? We already calculated that. My b is the square root of 1875, correct? So we'll just put the square root of 1875, plus or minus. My c is 50 plus or minus, and my foci we already know is negative 50, 0, and 50, 0. That makes sense, guys? And that's a hard question, because it's a word problem. But this is a very lifelike scenario. This is how they use the Lorentz system. This is how they navigate. Okay? It's pretty cool. Okay. Next, find the values of the vertices, the foci, the equations of the asymptotes, and then graph this sucker. All right, let me show you how easy this is when they give it to you like this, guys. First of all, who's the positive one, the x squared or the y squared? So you know it's an x-axis transverse. It's a y-axis conjugate. What's my a, guys? Heck yeah, plus or minus 3. So my vertices? 3, 0, because it's an x-axis transverse, and negative 3. Excellent. Okay, we do know my b. What's my b? Plus or minus 2, right? And then my c is going to be c squared equals 9 plus 4, so that's 13. So c equals square root of 13. So plus or minus square root of 13. My foci is on my transverse axis. So that's positive square root of 13, 0, negative square root of 13, 0. Now, please pay attention because I'm about to make magic. Okay, ready? My center is 0, 0. Great. My axis, my a, my vertices are 3 to the right from that and 3 to the left. 3, 0, bless you. Negative 3, 0. 1, 2, 3. You with me so far? Graph your b, guys. Up 2, down 2. When you have your a and your b, make a box. This is an imaginary box. This is not part of the hyperbola. This is, bless you, this is just going to help you graph this sucker. You with me so far, guys? Okay. Now, make a line that connects the corners through the center. Bless you. Make another line. Make another line that connects the corners through the center. Now, within this restrictions, within my asymptotes, graph the hyperbola. Don't cross the asymptotes. Don't cross the asymptotes. And then last but not least, you got to graph your your foci. In this case, the square root of 13. It's a little shy of 4. So it's like about like right here. And it's about like right here. And you are done. Like I said, parabolas are a lot harder than this. Does that make sense, boys? Who said no? Someone say no? Okay, we're good? May I continue? Okay, awesome. Next. Okay, give me 1 second, please. Okay, write the following hyperbola in standard form and find the vertices, the foci, and the equations of the asymptotes. Oh, wait. We didn't do the equation of the asymptotes here. Look, for this guy right here, what's my y-intercept? 0. I went down 1, 2 over 1, 2, 3. So it's plus or minus 2/3 x. Done. You with me? So right from what you graphed. Try to make your lives easy. Well, buddy, my y-intercept is 0, down 1, 2 over 1, 2, 3. That's my slope. Y equals mx plus b, remember? Thank you. Next. Now, I want to go ahead and write this in proper hyperbolic form. Find the vertices and the asymptotes, the whole 9 yards. All right, so this is what we've done 100 times already. Let's go ahead and complete the square. So let's get the x's together. 4x squared minus 32x. The y's together, minus 9y squared minus 18y, and get that constant over to the other side. Is everyone with me so far? I'm going to, from the x's, factor out a 4, giving me x squared minus 8x. I'm going to complete the square, which is b over 2 squared, which is negative 4 squared. I'm going to factor out a negative 9, which gives me y squared plus 2y plus, I'm going to complete the square, b over 2 squared, so that's 1 squared, equals negative 19. Now here's the part that you got to be careful with. Plus the 4 that you pulled out times the negative 4 squared. So that's going to be plus 4 times 16 plus the negative, actually minus the 9 you pulled out times 1 squared, so times 1. So now when I complete the square, I'm going to get 4x minus 4 squared minus 9 y plus 1 squared equals 36. I know that it's a hyperbola, so I'm going to have to divide 36 to both sides. And I'm going to get x minus 4 squared over 9 minus y plus 1 squared over 4 equals 1. Does that make sense how I did that, guys? You sure? Okay. Who's the transverse axis here? X, because the x is positive. So that means y is negative. Before we do A, guys, if you remember the formulas, okay, for your vertices, when you have an HK, it's going to be H plus or minus A for the K. Okay, the vertices are going to be H plus A, comma, K, and H minus A, comma, K. So my HK here in this case are, 4 and negative 1. Very good. What is my A value here? My A value is 3, right? Plus or minus 3. So my vertices, it's going to be H, which is 4, plus 3. So that's 7, comma, negative 1, the K. And H minus A, so that's going to be 1, comma, negative 1. Those are my vertices. My B is plus or minus 2. Okay? Don't worry about finding the covertices because there are no covertices. That B we use for graphing purposes. Now the foci. How do I get the foci? Well, C squared equals 9 plus 4. So C is going to equal the square root of 13. So that's plus or minus the square root of 13. And just like the vertices, the foci, when you have an HK center, it's H plus C comma K and H minus C comma K. So I'm going to erase this for a second. So I'm going to have H, which is 4 plus square root of 13, comma negative 1, and 4 minus square root of 13, comma negative 1. And you're good. You're golden. Okay? Is everyone with me so far? Does that make sense to you guys? Now's the time to ask. It's just a matter of plugging in those formulas, my brothers. You with me? Okay. Last one, and then we'll move on to the last section. You have one question. I hopefully have an answer for you. Sir. Yes, sir. It's the absolute value of the A, really. Thank you, brother. Because the A is really 3. It's a distance of 3. I just go plus or minus because you go to the right of the center and to the left, or above the center and below. But the actual distance A is actually 3, sir. Thank you, son. Thank you very much. Okay, graph this sucker. All right. Do I have an X transverse is X or Y? X. The conjugate is Y. A is 6. So my vertices are 6, 0, and negative 6, 0. Maybe I should learn how to read. There is an H and a K. H comma K. Thank you, my brothers. So vertices H plus HK is, first of all, 3, negative 2. So 3 plus 6. So we got 9, negative 2. And then 3 minus 6, negative 3, negative 2. Very good. Thank you, guys. The B is 3. Don't worry about that. The 3 is going to be part of the covertices. Yes, sir. Yes, sir. There should be a square there. Thank you. Okay. Now, the C. The C, we're going to have to figure it out. C squared equals 36 minus 9, which is 20. No, it's plus. So that's 45. So C is going to equal the square root of 45, which is 9 times 5. So 3 square root of 5? Yeah. So we got positive 3 square root of 5. So H plus C and H minus C. So 3 plus 3 square root of 5, comma K, and 3 minus 3 square root of 5, comma K. Now, let's graph it. So my center is 3, negative 2. Boom, right there. 6 to the right, 1, 2, 3, 4, 5, 6. Or you could just go 9, negative 2. Negative 3, negative 2. Now, from the center, go up 2, go down 2, make my box. That's my box. Connect this corner, this center, and that corner. Connect this corner, that center, and that corner. Go ahead and create your hyperbolas. And your foci is 3 square root of 5, so that's about 3 times a little over 2, so a little over 6. So 1, 2, 3, 4, 5. So it's like about there, my foci. And then this one, I don't have enough room, but I'd have to like go over here somewhere. Okay? And that would be it. Does that make sense, guys? You with me? I promise. Okay? Awesome. Now, let's move on. I am sorry, but we got to move on today. All right. Chapter 10 add-on, guys. I had an add-on section because this wasn't in your book. I don't know why it wouldn't be in your book, but it's very simple, okay? Um, Apparently I didn't post these online. I apologize. I will post them today before I leave. Don't worry about writing down all these crazy formulas and stuff for right now. I would just want you to focus and listen to what I'm saying, because I'm going to make this so easy for you guys. First of all, recognizing conic sections from a general form equation is what we're doing. Okay, that's what we're doing. We're recognizing it from a general form. And the general form equation is ax squared plus bxy plus cy squared plus dx plus ey plus f. If they ever give you some crazy thing like this and they say, what's the a? The a is what's in front of the x squared. That's the coefficient of x squared. They say, what's the e? That's the coefficient of just y. They say, what's f? That's the constant. Okay? That part's very simple to recognize. Today we will learn ways to recognize conic sections from the general form equation. Now, you have the first method, which I do not like. I do not like this method. But I am here to teach, not just give you a bias of what I think is right or what I think is wrong. That's not my job. My job is to give you all the information, and then hopefully you can disseminate on your own. So, for the general form of a conic section, please note that A, B, and C, they cannot equal 0 all at the same time. If A, B, and C do equal 0, okay, what am I left with? A linear equation. Thank you very much, son. Great job. So A, B, and C cannot all be 0 at the same time. Individually they can be, but they cannot be all at the same time. Now, I'm going to go over this really quickly because I don't like it. If you like working with formulas, if you can plug in b squared minus 4ac, okay, if you can find the b, the a, and the c, and you plug in b squared minus 4ac, if it's less than 0, but b equals 0 and a equals c, that's a circle. That's a mission. If b squared minus 4ac is less than 0, and either b doesn't equal 0 or a doesn't equal c, it's an ellipse. Mission. B squared minus 4ac is greater than 0. That's not that much of a mission. It's a hyperbola. And b squared minus 4ac equals 0. Not that much of a mission. It's a parabola. Let me show you how Mr. Morrow does it. And I don't know why I put method 2 there when there's nothing here, because method 2 is here. All right. All conic sections have their own equation form. In a perfect world, such conic section equations can be written as such. Let me give you some things to notice, and then you're going to see when I teach you the second one, you're going to say, oh my God, this is so much easier. In a parabola, you're either going to have an x squared or a y squared. Remember that. For a circle, you're going to have both x squared and y squared, and they're going to both be the same sign, and they're both going to have the same coefficient. For an ellipse, you're going to have a positive x squared and a positive y squared, but the coefficient a and the coefficient of y, c, are different. And in a hyperbola, you're going to have a y squared and x squared, but they're going to be subtracting from each other. If you can memorize that, guys, oh my God, you're so set. However, in the real world, conic equations can be rewritten in several different ways, making it more difficult to recognize. Luckily, there are a few characteristics of the perfect world equations that do not change. Learning these characteristics makes it easy to recognize what type of a conic section you are dealing with. So, given the conic section equation, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, or after arriving to that general form, after manipulating the equation, sometimes they won't put it pretty like that. Maybe they say ax squared is over here, and you got to subtract it to both sides to make it into the general form. Once you get to this general form, you got 3 questions you're going to ask yourself, guys. And if you can answer these questions, you're done. Are both x and y squared? If no, if only y is squared or only x is squared, stop, you're done. It's a parabola. Done. You don't have to do b squared minus 4ac and b equals this and a equals, forget that garbage. If they are both squared, keep going. If you have both x and y squared, do x squared and y squared have opposite signs? Is one of them positive? Is one of them negative? If they both have opposite signs, done. You stop. It's a hyperbola. Next and last question. With that x squared and y squared, do they have the same coefficient? Is the number being multiplied in front of the x squared and the y squared the same? If they are the same, stop. It's a circle. If not, stop. It's an ellipse. So if you have just one variable squared, an x squared or a y squared, parabola, done. Don't go on. If you have both x squared and y squared, but they are opposite signs, one is negative, one is positive, stop. It's a hyperbola. Okay? If not, keep going. If the signs have the same sign, if the squared variables have the same signs, they're both positives, for example, but they have different coefficients, it's an ellipse. If they have the same coefficient, it's a circle. You like that better than formulas? Let's show you how it works. Let's show you how it works. Okay, let's practice by classifying the type of conic section represented by each of the following. Okay, I've got an x squared and a y squared, so I know it's not a parabola, but x is positive, y is negative, it's a hyperbola. Very good. 3y squared plus 4x, and then I got a negative x squared here. You know that I'm going to bring this over, right? Right, to the other side. I'm going to bring this and this, but let's focus on this right here. I've got a y squared and an x squared. They're both positive but different coefficients. Ellipse. Yes. 6x squared plus 6y squared. Circle. 3x squared plus 4x minus y. Who's the bomb? Huh? No, not you guys. Me. No, I'm kidding. Of course you're the bomb. Does that make sense? Now, how does this help you? We'll tell you right after the announcements. Okay, guys. Last thing. I'm only going to probably be able to do a couple, but at least one is more than nothing. Both the x and the y are squared. However, they have different coefficients. That should let you know that you have an ellipse. Okay? So, right off the bat, if it helps you, go ahead and remember, okay, the ellipse. How does the ellipse work? Okay, it's x minus h squared over a squared plus y minus k squared over b squared equals 1. And I know that the a is larger than the b. And I know that the a is larger than the b. So let's keep that in mind, guys. I strongly suggest that, okay? All right, so now I'm going to go ahead and complete the square. So how about we do it the right way? X squared plus 2x. I'm going to complete it already. Plus 1 squared. And then I'm going to factor out, I'm trying to save time. I'm going to factor out a 4 from the y's, giving me a y squared minus 6y plus negative 3 squared equals negative 33, okay, plus the 1 squared, this guy, plus, great job, son, 4, which I factored out, times negative 3 squared, which is 9. Awesome, dude. Thank you. So now I have x plus 1 squared plus 4 y minus 3 squared equals 4. Very good. Divide by that constant. So I'm going to have x plus 1 squared over 4 plus y minus 3 squared over 1 equals 0. Come on, man. Equals 1. Now, I'm going to erase all this because I'm going to try to graph this, okay? See if I can graph all of this. Okay, we're all done there. Okay, now you know exactly what you got. That's my equation. Okay, what's my conjugate, or what's my major axis? The x, right? Well, let's get my center. My center is 1, 2, 3, 1. What's my A? 2. So go 2 to the right and 2 to the left, since I have an x-axis or parallel to x-axis. My B, my covertex, for my covertices, up 1, down 1. And that's it. That's your ellipse. Oh, but I need to find the foci. Okay, remember, c squared equals a squared minus b squared here. So c squared equals 4 minus 1. So c is going to equal the square root of 3, which is just shy of 2, right? Just shy of 2. So your focus is about there and about there. And that's that. Does that make sense, guys? Yes. Negative 1, 3. That's what I... Oh, wait, no. Epic fail. I went 3, 1. Wah, wah, wah. Let's do it again the right way. Negative 1, 3, ding dong, is here. Because Moro's a little stupid. And then from here, you go 2 to the right. I'm sorry, guys. 2 to the left, ding dong. Up 1, down 1. That's my ellipse. And the C is still the same. Square root of 3, okay, that's from the center. So that's a little bit less than 2 from the center. So it's like about there and like about there. Okay? And I know this is a very small graph. I apologize. Maybe this will help a little bit. Maybe. Maybe not. But that tells you everything you need. That gives you the vertices, the covertices, and the foci. And that's what your homework is, guys. Right? Recognizing it, completing the square, rewriting it, and then graphing it. Is that cool? Okay. You have two homeworks, guys, and they're both valid. Have a great day, and God bless you. Bye-bye.